Yes. I am Dr. Sharad, Assistant Professor, Department of Chemistry, KTCM College, Nashik. In this lecture, we study about analytical chemistry, revision of analytical chemistry. In this lecture, we study about what is meant by the analytical chemistry, then what is meant by the chemical analysis, qualitative analysis and their types, quantitative analysis and their types, stages in chemical analysis, sampling and types of chemical analysis, factors affecting on choice of methods. These are the points which was studied in first year introduction of. In this lecture, we can revise all these terms because these terms, analytical chemistry, in which qualitative and quantitative is the most important term. Depending on that, the next chapter is depending, that is errors in quantitative analysis. So we can see all these points one by one. So analytical chemistry. So what is meant by the analytical chemistry? The definition of analytical chemistry is like that. Analytical chemistry is a branch of chemistry that deals with the separation, identification, and quantification of the components present in the sample. So here, these three terms is most important in, if you can look the analytical chemistry: separation, identification, and quantification. These are the important terms. So role of analytical chemistry is important in all field of science and technology like agriculture, forensic, pharmaceutical, food industries, environmental, and material science. Because if you can see the pharmaceutical, the production of any tablets, they are going through some analysis if it reaches to the market, and that time the analysis is done on the basis of qualitative and quantitative analysis. That is the parts of analytical chemistry. If you can see the food industry, the safety is most important. At that time the analysis is required. Environment, that is the water quality, air quality, soil quality, you have to test by using the, that is the chemical analysis, or you can say the analytical chemistry. That is the applications of analytical chemistry in all that field, all that fields. So the important term related to the analytical chemistry, that is the chemical analysis. Why it is chemical? Because in terms of chemistry, the chemical analysis is important. So what is meant by the chemical analysis? The chemical analysis is defined as the use of process or a series of process to identify, most important thing, that is to identify and quantify the components present in the sample. From this, it is used for the determination of structure of chemical compounds. If any compound is present in the mixture, you have to identify with the help of certain process. From the process, at the end, you got that compound structure. From that structure, you can identify the compound is XYZ or whatever. Depending on this, the chemical analysis are play important role in two parts, that is the qualitative and quantitative. These are the two important concepts related to the chemical analysis. The chemical analysis having two parts or divided into two subparts, that is the qualitative analysis and quantitative analysis. These two terms, that is qualitative and quantitative, are the heart of analytical chemistry. Are the heart of analytical chemistry. Why? Because any analysis are thing, it may be qualitative type or quantitative types. These are the two terms in which first, that is the qualitative, means what is present, that is the identification techniques or identification types of analysis, and quantitative means it is how much is present, that means the quantification. These are qualitative means identification and quantitative means quantification. These are the two important terms. Identification, go for the qualitative analysis. Quantification, then go for the quantitative analysis. So we can see one by one what is meant by the qualitative analysis and what is meant by the quantitative analysis. So qualitative analysis, it is defined as or deals with the identification of elements, ions or compounds present in the sample. In other words, it is said that the qualitative analysis means what is present in the sample. So whatever the sample is coming or sample you want to analyze, in which first you have to identify what is present. What is present in that sample, that types of analysis is known as qualitative types of analysis. That is the qualitative analysis. It is again divided into two parts or types, that is inorganic qualitative analysis and organic qualitative analysis. So inorganic qualitative analysis in which ions of elements are separated and identified on the basis of precipitation with specific reagent. With specific reagent. That is ions of elements which is having capacity or capability to precipitate with some other chemical reagents. So on the basis of this, the inorganic qualitative analysis are done. For example, detection of calcium, detection of magnesium, like this. Or inorganic qualitative analysis in which group first, group second, A, second B, third A, third B, fourth, fifth and sixth. Like this, you have to analyze the inorganic compounds, the inorganic qualitative analysis. Second type, that is the organic qualitative analysis, in which the elements or compounds are identified on the basis of selective chemical reactions. So chemical reaction is going on like this: identification of acid, base, neutral or phenolic compound on the basis of some chemical reaction. You got the precipitate and you can say that this compound is acid, this compound acid is present or base is present or phenol is present or compound, all tests are negative, then you can say that the compound is neutral. Like this you can analyze the organic compound in qualitative analysis. And further, if acid is present, then go for the next analysis, which types of acid is present. Maybe by using the spectroscopic technique, you got the IR. From that IR, you got the stretching frequency of carbonyl group, ester group, like this, or NMR also. So these are the types of qualitative analysis. Qualitative means if in which you can think about quality, or qualitative means that is the what is present in the sample. These are the important terms. What is. Then next, that is the quantitative analysis. Quantitative itself, it indicates the quantity. That means how much amount. So quantitative analysis deals with how much of one or more constituents are present in the sample. Or in other words, quantitative analysis means how much amount is present in the sample. In the quantitative analysis, you know the compound, but you can find out how much is it. The qualitative analysis, you can find out which compound is present, and in quantitative analysis, you can find out how much amount of that compound is present. These are the basic difference. So quantitative analysis are having two types: weight or classical methods of analysis and instrumental methods of analysis. In weight or classical methods of analysis, gravimetric, titrimetric and volumetric are involved, and instrumental methods of analysis in which four major categories are given, that is electroanalytical methods, thermal methods, spectroscopic method, separation methods, and special techniques like X-ray methods, radio analytical techniques, kinetics methods and optical methods is given. We can see one by one. That chemical analysis having two types: qualitative. Qualitative means what is present. In that qualitative having two types: one is the organic and another one is the inorganic qualitative analysis. That is detection of calcium, magnesium. or FTIR NMR like this. Then next, that is the quantitative analysis. That is nothing but the how much is present. You have to find out in which weight or classical methods of analysis like gravimetric and volumetric, and instrumental methods of analysis in which electroanalytical techniques or separation methods. So we think about this qualitative means what is present. This is the most important, and it is how much is. In the next lecture, we can see that the errors in quantitative analysis or volumetric analysis that is related to the weight or classical methods of analysis. So for that purpose, what is meant by the quantitative analysis? Quantitative analysis weight methods in gravimetry. What happened in the gravimetric analysis? Gravimetric in which the amount of reagent needed to complete the reaction and reaction in which the amount of product from is measured. Here amount of product is measured by gravimetrically, titrimetrically and volumetrically. Volume is then instrumental methods in which electroanalytical methods like volumetric methods, colorimetric methods and potentiometric electro. In this, if you can see that the volumetric methods in which the measurement of current at a microelectrode at a specific voltage is used, that is the voltammetry. You can consider coulometry in which measurement of current and the time needed to complete an electrochemical reaction, that is coulometry. Potentiometry in which the measurement of potential of an electrode in equilibrium with an ion to be determined. And last, that is the electrogrammetric method in which the electrolysis is carried out and the material deposited on one of the electrode is that is the electroanalytical chemistry. If you can consider the thermal methods of analysis in which thermogrammetry. In the thermogrammetric methods, the measurement of weight or energy change as a function of temperature is recorded. In the thermal gravimetric, record the change in weight with temperature. DTA, that is the differential thermal analysis in which record the difference in temperature between test substance and inert reference material. And DSC, that is the differential scanning colorimetry in which the energy needed to establish a zero temperature between test sample and reference material. The next, that is the spectroscopic methods. In that spectroscopic method depends on the radiant energy, either absorbed, emitted by the sample. If you can consider the absorption methods in which atomic absorption spectroscopy, ultraviolet spectroscopy, infrared spectroscopy, like this. Then ICP is the one method in which emission method is included. That is the ICP or flame, in which emission is measured. Then fluorimetry in which the fluorescence or emitted radiation is measured. Then separation techniques. Which types of techniques? That is the chromatography. All of you know that the chromatographic technique is known as a separation method or separation technique, like thin layer chromatography, high performance liquid chromatography, gas chromatography, and mass spectrometry. These are the separation techniques. By using these techniques, the separation of mixture are done. There are other important techniques like X-ray methods of analysis, radio analytical techniques. In X-ray, that is the X-ray fluorescence or XRD, X-ray diffraction methods, which is generally used for the material science analysis. XRD, radio analytical technique also used for the neutron activation analysis or isotope dilation analysis, radioimmunoassay, radiometric titration, like this are included in the radio analytical techniques. Then last, that is the kinetic methods and optical methods. So in the kinetic methods, the rate of reaction is measured as a function of amount of catalyst. That is the kinetic methods. And in the optical methods in which the refractometry and polarimetry is used. These are the methods of analysis. If you can go for the quantitative analysis, you go for this four important types, that is analytical methods, thermal methods, spectroscopic methods, separation methods, and these are the special techniques: X-ray methods of analysis, radioanalytical techniques, kinetics, and optical methods. So stages. This is the most important part in the analytical chemistry. When you go for the analysis of any compound, chemical methods are having 8 stages, or you can say steps. You can see one by one. That is the selection of method. For the complete chemical analysis, selection of methods is important. That is the first point. The analytical method to be used for the analysis is selected. If you want to analyze the sample for the sample for the analysis in which method is used. If sample is solid, then which method is applicable. If sample is liquid, then which method is applicable. If sample is gaseous, then which method is applicable. For example, if you want to analyze the metal which is present in the soil, for that purpose you can select the instrument or methods of analysis like AS or ICP. If you can select the method AS, the need of that AS is the compound must be in the gaseous state or sample must be in the gaseous state. For that purpose, you can select the method sample, go for the analysis. That sample solid sample get converted into the liquid and liquid get converted into the gases. In this way, you go for the analysis. So this is the first step in which you have to select the methods of analysis, maybe the quantitative or quantitative, to obtain a representative sample. These are the most important parameters because on the basis of this representative sample, your results is depending. Your results is depending. The representative sample is must be all of the components and their amount present in the actual material. That is the representative sample. For example, in the classroom, one class representative is one class representative is that is you can say that the CR, which is having good marks, which is having the good communication with the all students. That's why it is called as the class representative. So like this, you can select the sample in which they can represent the all sample, represent the all sample. That is the representative sample in which all quality are present in that representative sample. In the next step, the preparation of sample for the analysis. Whatever the sample you have to select as a representative sample, that representative sample must be able to prepare for the analysis. If you can go for the analysis on AS, you can select the soil sample, then soil sample in which you can apply for the representative sample, you can apply the pour or quarter method in which that representative sample must be prepared for the analysis by using some chemicals. Then preparing solution of the sample. Then for the analysis, some solution must be required for the standardization purpose or for the sampling purpose. This here you can select prepare the sample for analysis, and here prepare the solution of the sample. For that purpose, you go for the standardization method or working standard method. Like this, you can prepare the interface eliminating interference, any chemical species other than the analyte present in the sample which affect the measurement of the analyte and causes error in the analysis, it is called as the interference. That means here interfering elements or eliminating interference means You can analysis of compound of interest rather than other compound is present that you have to eliminate or remove in this step. This step. Then performing the measurement. The results of every analysis are based on the final measurement of analytical properties or physical properties which is reproducible manner. That means you have to analyze any compound for the first time. Again, you have to analyze same compound for the second time. The measurement should be the same. Measurement should be the same. If the sample is same, condition is same, then you have to perform the measurement. After that performing, you can go for the calculation of results. And last, that is estimating the reliability of the reported results. That is most important. Reliability. These are the most important terms. Reliability, accuracy, and precision. If you can perform the measurement, your measurement should be the reproducible. That is, your analysis should be the reproducible, or you can say having the good precision. Good precision. So these are the stages involved in the chemical analysis. Selection of methods, obtaining representative sample, preparing sample for analysis, preparing solution for the analysis, eliminating interferences, performing measurements, calculation, and lastly, estimating the reliability of reported results. These are the key points of analysis, and each point you have to work out very fast for the analysis. Then we go for the sampling. In the analytical chemistry, sampling is most important point because all the analysis are depending on the sampling. If you cannot collect the appropriate sample, then your whole analysis are wrong. But whatever the steps we can see in the previous, that is the stages in chemical analysis in which sampling or you can say representative sample are most important because all the steps are depending on that representative sample. A chemical analysis is performed on a small amount of material which we analyze. This sample should be the representative of all the components and their amounts present in actual bulk. This representative sample is called as the gross sample. The process of obtaining that gross sample is called sampling. It's called sampling. So there are two concepts about the sampling, that is the homogeneous and heterogeneous. So homogeneous, it is easy to get the gross sample. However, when the bulk is heterogeneous, it is difficult to obtain the gross sample. The size of gross sample may be vary from few grams to kilograms depending on the types of bulk material. Sampling, heterogeneous and homogeneous. These are the two concepts. If compound or sample is homogeneous, then it is easy. But if the sample is heterogeneous, then it is difficult to obtain the representative sample. So we can see that the solid sampling, liquid sampling, and gas samples. How to sample solid? In the solid sample, the substance is first reduced to uniform size, then the mass of sample is reduced. The size of sample is reduced by using the crushing medium, then it is used in diamond mortar and pestle. Use the crushing, and that sample is again go for the oven to heat or dry some times. After that, put in the hot air oven. That sample having the constant weight, then it is used for the analysis. In the solid sampling, there are two concepts is given, that is the cone method and quaternary methods, quarter method for the representative sample. What happens in the quaternary method if the sampling having 10 kg sample, In that 10 kg sample, you make the four equal parts. Out of these four equal parts, two opposite parts are get rejected. That means if the sample is 10 kg, then it may be reduced up to the 5 kg. Again, that 5 kg having equal four part and two opposite part are get rejected. Only 2.5 kg sample is remaining, and that 2.5 kg sample again you have to uh, make four part. Out of that four, two part get rejected. That means 1.25 kg sample is remaining, and that to 1.25 kg sample you can collect the rejected sample. These are the quaternary methods. In terms of liquid sample, the liquid sample, if it is homogeneous, then sampling is simple, and it is stored in drum or column of liquid is removed from the top of the bottom by using the thin pipes. The procedure of sampling is difficult if the liquid is mixture of two or more liquids, that if the liquid is volatile in nature. If the sample is a volatile in nature, then it is very difficult to analyze the liquid sample. Then gaseous sample. Gases sampling may be done by collecting them in the flushing and the displacement of liquid. The liquid must be one in which the gas has little solubility. For example, mercury is the most commonly used liquid in the collection of atmospheric sample for the analysis. The volume of gases sample taken and duration of sampling are important. Air is allowed to pass through the series of fine filters to separate particulate matter, and then through columns, the solution where chemical reaction take place and desired component are get trapped for the gases. These are the three types of sampling. Then types of chemical methods of analysis, in which proximate analysis, partial analysis, trace constituent analysis, and complete analysis. So we can see one by one what is meant by the proximate analysis. In the proximate analysis, the amount of each element in the sample is determined, but not all the compound. In the partial analysis, selected constituents in the sample are determined. In the trace constituent analysis, the partial analysis that determines the specific component present in very minor quantity. That is the stress constituent analysis. And last one, complete analysis, in which the property of each component in the sample, a sampling size, and proportion of analyte is determined. That is the complete sampling. Rather than this, the size depending analysis, that is the size depending. Sorry, macro, meso, micro, submicro, trace, micro trace, nano trace, which is depending on the sample set. If you can consider the macro, then it is having the less than 0.1 gram. If semi, that is the 10 raised to minus 2 gram. Micro, that is 10 raised to minus 3. Submicro, that is 10 raised to minus 4 gram. Ultra trace or trace, that is less than 10 raised to minus 2 to 10 raised to minus 4, and it is in the ppm. All these are in the ppm level. Also, there are four major terms are given, that is the major, minor, trace, and ultra trace. So major constituents, that means the constituents which is present in the 1%. If the amount is 0.01 to 1%, then it is called as the minor constituents. Then trace, in that trace, the quantity or amount may be less than 0.01%, and if it is then the ultra trace, that is in the ppm level. So these are the sample size based analytical methods of analysis. And last point, that is the factors affecting on choice of methods. So if you can analyze any compound, you can select the method of analysis. Some parameters are most important for the selecting of that methods or choice of methods in which types of analysis. So types of analysis in which it may be elemental level or molecular level. It is routine or occasionally analysis, which is most important. The nature of material. For example, radioactive substance, corrosive substance that may be affected on the analysis. That is the major problem. That is the nature of material. Then interferences present in the sample. Rather than our interest of compound, some other impurities are present that can interfere in the analysis. That is the that can affect the choice of methods. Then concentration range in which the analysis is carried out. It may be ppm, it may be the major, minor, trace or ultra trace. Level of concentration you got the analysis. Then accuracy. This is the most important point because whatever the chemical analysis is done, that is depending on the results, which is depending on the accuracy. Then facilities, infrastructure, equipment, and time requirement. These are the some important points on which our analysis or methods of analysis is important. If you can analyze the compounds in a blood sample in 2 days, but it requires in the 1 hours, so you can prefer that 1 hour methods, not 2 days methods. In the hospitals, like some important pathological parameters are there, then you can go for that types of analysis. Replicate analysis and non-destruction methods, which are the most important thing in the analysis due to nature of sample. And you can need to replicate analysis. That means you can reproduce that result how many times. It may be most important. So last, in this lecture, we can study about what is meant by the analytical chemistry. That is identification, separation, identification, and quantification. Chemical analysis, which is having two types, qualitative and quantitative. Quantitative analysis, that is nothing but what is present and their type, that is organic qualitative and inorganic qualitative analysis. Then quantitative analysis, that means how much is present and their type, that is the weight or classical methods of analysis and instrumental methods of analysis. Stages in chemical analysis, in which 8 stages. In which first one, selection of methods, obtaining a representative sample, preparation of sample for analysis, preparing solution of sample, eliminating interferences, performing the measurement, calculating the results, and last one, estimating the reliability of reported results. Then sampling and types of chemical analysis. There are three types: solid, liquid, and gases. Then types of chemical analysis in which proximate, proximate, partial, trace, and complete analysis. Meso, micro, sub, micro, trace, ultra trace, micro trace, nano trace. Then major, minor, trace, and ultra trace type of chemical analysis. And last one, that is factors affecting on choice of method, in which types of analysis, nature of material, interference, concentration range, accuracy, facility, time required, replicate analysis like this. So thank you. In the next lecture, we can see the errors in quantitative analysis. Thank you. Thank you very much.